Okay, this is lesson 7.6b, and that's where I left us, finding x is 19 over 15. Alright, so let's go ahead and see if we can move stuff out of the way so that we can start solving this. Alright, so we can get rid of this here, and we already put our answer up above. So I'm going to leave that stuff there because I'm probably going to need that. So I found the x value. Next step is, let's say we find the y value. Okay, so we are going to look for an equation that has an x and a y in it. X so that we can put this in its place, y so we can solve for y. So we're going to look at one of these two problems. Again, it doesn't matter which one we choose. So let's go ahead and just choose the top one. And we're going to put 4 times 19 over 15 there. Alright, so let's see. 4 times 19 is 76 over 15 minus 2y equals 4. And we're going to get negative 2y equals 4 minus 76 over 15. Okay, so common denominators here. (60 over 15 instead of 4). Negative 2y equals negative 16 over 15. I know this is a pain, isn't it? And let's do that. Negative 2 over 1, which means we invert and multiply. Okay. And these go away. So then we have 16 over 30, giving me a y value of 8 over 15. That was not fun, but again, you're going to deal with fractions. Alright, so let's see what we can get rid of here. So again, so we have, more room to do the work that we're trying to do here. Alright, so let's move this stuff back down again. We don't need the pink there because we use that to find y. What we're interested in is this here. And again, we found y to be, what was it, 8 over 15. I don't know why it disappeared. Alright, so now I'm going to find an equation that has a z in it because that's what I'm looking for there. So I'm going to go to one of these problems here, and again I'm going to pick the easiest one. So I think I'm going to pick that one. And I'm going to put my x and my y. And my z, and that gives me 3. So distribute. Combine these. And then I'm going to raise this all up. Come on, get this stuff out of my way. And I'm going to move this over. Common denominator. Negative z equals negative 1/15. And I just change the signs, and I get 1 over 15 there. Okay, and this was, what, 8 over 15, is that right? Yeah. And that's it. There's your answer. Okay, so this is example number 3. And again, the first step is look for two equations that it would be real easy to get rid of one of the variables. So these two here, probably get rid of the z's because I can multiply this whole thing by 2 so that this is a 2 here and here. I could do this one and this one for the same reason. I can make that a 2 pretty easy. So those are probably the better. I mean, I could do this one and make this a 4, but you know, you work with smaller numbers, it just seems like it'd be that much better. Alright, so let's go ahead and let's get rid of the x's. Let's use the first and the third one. So 2x plus 3y minus z equals 5. We're going to multiply this by negative 2. So that becomes negative 2x plus 8y minus 6z equals negative 10. Okay, add those together, those go away, that becomes 11y minus 7z equals negative 5. Okay, so there I've got two variables in one equation. Alright, so I'm going to do the same thing again. And since I got rid of the x's using the first and the third equation, I have to get rid of the x's again. So I'm going to use the first and the second one and get rid of the x's there. So I'm going to multiply this thing by negative 2, and I get negative 4x minus 6y plus 2z equals negative 10. And so I changed the first one. The second one I'm not changing at all because that's already a 4. Okay, so let's add these together. Those give me 0. These, give me 0. Those give me 0 equals 0. Is that a true statement? Yes. Then we're left with a true statement, which means once we hit that, it doesn't matter where in the world we come to. There's really no single number. I mean, there's an infinite number of solutions. So at this point, because these are equal, there's an infinite number of solutions. If we got an answer like this, that would mean there are no solutions. So, infinite number of solutions, you're done. You don't have to go any further there. Alright, so let's jump to example number 4. And number 4 we're going to get for an answer. I'll just lay it out there. You're going to get the null set. So you're going to do it the same way. It doesn't hurt to keep practicing how to do this. Okay, and you make the decision on what you're going to find here. So let's look at the first and second one. Since one has an x and one doesn't, we'll multiply this first one by negative 3. So we get negative 3x plus 15y minus 12z equals negative 24. And the second one we leave the same. Add, those are 0. Negative 24 plus 7 would be negative 17. So there we have a y and a z. We got rid of the x. So let's look at this one and this one. So we're going to take the top one, we'll do this one in red, and we'll multiply it by 9 so that it matches that one. 9x minus 45y plus 36z equals 72. And then let's take the third one and write it as is. Okay, those go away. We end up with negative 48y plus 42z equals 77. And we'll put that down with this one, and we'll put it in green. Negative 48y plus 42z equals 77. Alright, so there's our system there. And let's see, let's make the 16 a 48 by multiplying the whole thing by, let's say, 3. And then that gives us a 48y minus, let's see, 14, 28, 38, 42, 17, 34, 44, 51, okay, so I just rewrote that there, and let's see what we get here. 0, 0 equals 51, 61, 71, 26. So does 0 equal 26? No, it does not. So because they're not equal, then we get the null set for an answer, and we just stop there. We don't have to continue any further with that. Okay, let's look at example 5. And we'll do example 5 and 6 in the next video.